In this experiment, we're going to explore some electrochemistry, that is to say, some redox chemistry. We will do this by placing a solid piece of metal into a solution of ions. In this apparatus, on the left-hand side, we have a test tube in which we're going to place the solid metal, we're going to call it B to be generic, into a solution of metal A's ions. And on the right-hand side, we've reversed it so that we're now placing solid metal A into metal B ions. In this experiment, we want to be looking for something to happen. We want to make some observations. On the left-hand side, we could see that almost immediately there was a darkening of the grayish metal. And this is clearly evidence of a reaction, a spontaneous reaction that occurred without us doing anything. The reaction that you might observe might not be as dramatic as this one. Perhaps it will be a very slow reaction where the darkening of the metal or the tarnishing of the metal takes place over a longer period of time. Or perhaps there's some bubbles that appear at the surface of the metal, or perhaps there's even a color change of the solution. But the important thing is to be patient and make sure you monitor whether something occurs. On the right-hand side, we can see that even after the period of a few seconds, there is no evidence of a reaction. There is no color change, and there are no bubbles. The solution is not changing color, so clearly not a spontaneous reaction in the right-hand side test tube. The fact that the left-hand side test tube produced a reaction which was spontaneous tells us ahead of time that we know the standard cell potential for this future cell is a positive value, and that furthermore the reduction potential for the ions in the solution must be larger than that for the metal B.